Vanakkam. Welcome to this course on biomedical instrumentation. We have been looking at ventilators. In this video, we will look at some of the breathing sequences that are used in ventilators, or what are the various types of ventilation methods that are there. Like what are the approaches to ventilation methods that are there. We know from our current discussion of ventilators how biomedical engineering has practically revolutionized healthcare. It's a huge step forward, especially ventilator being one of the most sophisticated systems. It's an excellent example. It's that quintessential engineering example where you have closed loop control. So, this serves as one of the best examples of sophisticated engineering in healthcare. Something to keep in mind. Now, what has led to this development? Essentially, decades of clinical observations, decades of clinical data or observation. Okay. And an understanding of physics of gas flow and gas exchange. And what we need to focus on are interactions between patients and the ventilators. There are still some engineering challenges that are there. So, we will focus our attention in this video on these three topics: continuous mandatory ventilation, we will CMV, IMV and CSV. We will call this briefly as CMV, IMV and CSV. What do these? By the way, during COVID-19, there was a need to critically understand the meaning of these. There was an absolute need for caregivers, healthcare professionals to clearly understand the difference and the meaning and the distinct features of these three. Absolute need during COVID-19 when it played a different methods for different patients, different methods for the same patient during the course of treatment. As the patient is improving or worsening, the method will vary. So, essentially each of this mode, each mode represents a different philosophy. It's a philosophy towards control. Each of them is a philosophy. CMV essentially refers to complete authority. Essentially is a situation in which the ventilator exerts complete authority over the patient. IMV has some form of shared control, whereas CSV is essentially, many times in the slides we have referred this to as patient cycle. This is essentially patient triggered. Patient gives the lead, but the work itself is still done by the ventilator, because if the patient can breathe, then why do they need ventilators? That. Okay. So, these three represent three different philosophies. The first one is CMV, continuous mandatory ventilation. One of the more popular methods of this is the assist control mode. This is similar to car's cruise control, that is going to maintain speed. If you have ever worked with a car that has a cruise control, it will simply maintain a given speed, that is the car's cruise control, except that in some cases when there is a need to override the car's cruise control, the driver may be able to override the car's cruise control. But in this case, the patient cannot override. That's a critical difference between car's cruise control and this case. Car's cruise control essentially maintains the speed within a small range. In some cases, such as the assist control mode, it is possible that the patient will trigger the breathing. When the patient cannot breathe on their own and there are no spontaneous breaths, this essentially does not allow spontaneous breaths to happen. Between the breath cycles, spontaneous breaths will not happen. So, the ventilator is practically completely responsible for the entire breath cycle. We can adjust for pressure, volume and flow waveforms, and ventilator will operate as per the preset values of pressure, volume and flow waveforms. Now, you can also adjust the durations. So, you can not only adjust pressure, volume, flow waveforms and this, you can also adjust the time. So, and there are different types of target schemes. We will discuss target schemes in a future video. This will practically work with all types of target schemes and different types of control. It can either work with volume control or it can also work with pressure control. Usually, this is the first mode that is deployed in case of emergency. Why is that? Because this is the simplest and this is going to assist the most required or most critical cases. So, this is usually the first use in case of emergency. Recall our relationship between pressure and flow. V dot is delta P by R, where R is the resistance of the entire resistance. Now, you know, the pressure is essentially the sum of, I can say that there is a total pressure which is essentially the sum of the elastic pressure plus the sum of the resistance. Now, what is this elastic pressure? This is V by C, not. Whereas, what is the pressure due to the resistance? This is V dot times R, right, not. Plus, is this all? No, the most important thing is then the requirement to keep PEEP, positive end expiratory pressure. Now, this is the total pressure, recall, this is the total pressure. So, essentially this pressure depends on both the elastic component and the resistive component, essentially due to both the compliance and the resistance, both of this. Then you have the intermittent mandatory ventilation. In this case, you can compare the situation to a hybrid car that can switch between petrol and battery as required. Depending on the situation, the car might run on battery or it might run on petrol. I am not talking about electric cars, I am talking about hybrid cars, those that can run both on battery and on petrol, that can switch smartly between petrol and battery. In this case, the patient can have spontaneous breaths when between ventilation cycles. So, the ventilator allows the patient to take a natural breath when needed. But when the patient is not able to breathe, the ventilator completes a mandatory sequence as per the preset values. So, it is doing the mandatory ones and then it is also allowing the patient to take spontaneous breaths whenever needed, not necessarily between every 2 mandatory cycles. The breath sequence may or may not sync with the patient's breath cycle, but there is a need to have proper synchronization, because depending on the specific mode and the specific model and the specific set values, it may or may not sync, but there is an absolute need to sync. We will discuss why later. Sometimes what will happen, the spontaneous breaths may suppress the mandatory breaths. Different manufacturing companies, ventilator manufacturing companies have different algorithms that deal with such a situation in which spontaneous breaths suppress the mandatory breaths. Usually the device takes it as a trigger and then acts accordingly and gives a command to breath. There are modern algorithms that ensure there is proper synchronization between patient breath and the machine's breath. This is used in a situation in which the patient is recovering, is in some form of partial recovery and is able to do at least some spontaneous breaths. Obviously, in the previous case, this is the emergency go-to first method, that is CMV. Second one is when the patient is recovering, so as to initiate the weaning situation, so that the patient can eventually get out of ventilation. Weaning, not from ventilation, weaning from ventilation. For that purpose, this method, this sequence is quite often used. Actually, the pressure time profile is actually quite complex, because the total pressure is the sum of mandatory pressure plus the spontaneous pressure, except that you actually don't have an idea of the spontaneous pressure time curve. Now, that is something that the system will have to sense using its sensors. So, it is a complex time dependent pressure waveform, not a trivial thing to model and understand. So, it is quite complex on this. It might be useful to consider work of breathing. What is work of breathing? We know this. Work of breathing is essentially integral of the muscle pressure times dV, is not right? Sinking is absolutely critical in this type of ventilation. In this mode, sinking is absolutely critical. You need to know when the patient is attempting to breathe, otherwise you can't really, just because if you don't, because if you are out of sync with the patient, then you might get into a lot of problems, right? Spontaneous breath, if the patient is taking, doesn't mean that the patient has completely recovered or is in a very good stage of recovery. The depth of the breath is also important. It is not merely the fact. It might be that the patient is breathing, but the breaths are shallow, like that, just a very brief breath. So, both spontaneity and depth of breathing are important. Both of these are important. The third is the continuous spontaneous ventilation mode. This is the assist mode. This is the situation in which the patient is able to breathe, but when the patient is struggling, when the ventilator provides support, assist. This is the assist mode. This is akin to power steering in a car. The driver of the car is turning in a particular direction, but the power steering will amplify the turn. Right. So, it is not that the driver is not turning, the driver is also turning, but the steering is turning even more than the driver. This is the power steering type of situation. This mode is used when the patient can breathe and has some amount of spontaneous breaths. The ventilator provides assistance to the initiated inspiratory phase, and the patient, it's usually patient triggered or patient triggers inspiratory phase. The sequence is patient cycle. What it means is that essentially patient triggered. And the ventilator compensates for the breath if the target is not reached. If the set target, whatever that target might be, that might be volume, duration, pressure, whatever it is. It is possible to set some values of expected pressure, volume or flow in the ventilator. Ventilator will operate as per the preset values. First, it will wait for the patient to finish, try to finish the breath. If not, the ventilator will finish the breath for the patient. Right. In this case, timing is absolutely critical. Timing is critical. timing of the breath and the as in timing of the assisted breath is absolutely critical, right. CSV does not mean that the patient is breathing on their own, it just means that the patient is triggering the breath, that is what it means. It only means that the patient, the breath initiation and termination are triggered by the patient, that is what it means. In summary, we looked at 3 modes of ventilation, 3 breathing sequences in ventilators, essentially continuous mandatory ventilation, intermittent mandatory ventilation and continuous spontaneous ventilation. Essentially the sequence in which this will go in the ICU or critical care unit is from CMV to IMV to CSV to no support. You need to decide, you need to have an idea of which particular method to use. You can have a rough algorithm like this. Let's say first you consider CSV. If work of breathing is excessive, then increase pressure. Increase the support, increase the pressure support. If dyssynchrony is unacceptable, if dyssynchrony is there, then adjust trigger, adjust the sensitivity of the trigger. Else use IMV or CMV. This is approximately the algorithm that you must use to choose which method to use. With this, we come to the end of this video. Thank you very much for your attention.